we were discussing about the coefficients that are added at the back of these molecules. These you can think of coefficients as moles. Okay. Now, this is what I wanted to tell you regarding the equation balancing. Okay. Now, we are not going into the details of the mole ratio. If you want, we can cover that, of course, in the next lecture, but not for right now. This question doesn't require. Moving towards the concentration. So if something has, for example, 0.7 moles, okay, and the unit of milliliter is used, okay, now 1 liter is equals to 1 decimeter cube. Remember that. Over here, they have given 0.7 moles and they've given the volume. You just have to divide in order to get the concentration. So concentration is basically the number of moles that are present in a volume of a substance. So let's solve this question. What is the concentration of a solution? So basically 0.7 moles is given and the volume is given, right? Now, if, for example, I have the concentration formula is number of moles and divided by the volume, okay? Now the number of moles over here is 0.7 and these are the number of moles. 400 is basically the volume, but 400 is in milliliters, so I have to divide it by 1000 to make it liters, which is decimeter cube, the standard unit. So 0.4, which is liters or decimeter cube. Now if I divide this 0.7 by 0.4, I get the concentration, which is 1.75 moles per liter or moles per decimeter cube. Okay, so hopefully this clarifies and meets enough criteria for doing our question. Now moving towards the question. This is the question. In an experiment, 2 moles per decimeter cube of nitric acid was added from a burette to a conical flask containing 25 centimeter cube of aqueous sodium hydroxide. The pH of the resulting mixture was recorded as nitric acid was added. You know the pH basically is an indicator, universal indicator, and the graph shows the results of the experiment. So it's pH versus the volume, okay? Here the concentration, so it's basically turning from alkaline to acidic, okay? Now, the first part of the question asks, write a balanced chemical equation for the reaction between sodium hydroxide. Now hydroxide is there. I've already told you that this word hydroxide basically means it's basically a base, and this word is nitric acid. So basically it's what kind of a reaction? It's neutralization reaction. Sodium hydroxide plus nitric acid gives salt and water. Water I've made, and salt is sodium nitrate. Now let's see if it's balanced. 2 hydrogens, 3 oxygen, 4 oxygen, 3 plus 1, 4 oxygen. It's balanced. So this is a balanced chemical equation. Moving on to part B. On graph, you have to mark the end point of the reaction where complete neutralization takes place. Of course, the neutralization will take place wherever the pH will become 7. So you will mark the point 7 on the graph. This is the end point. Drag it down to the volume of nitric acid and you will find out that it's 12.5 moles per centimeter cube, that is of the nitric acid for complete neutralization. Think of the experiment of titration. Remember, we added acid to the base to neutralize it, and then we recorded the volume. So the question is basically similar to that. Moving ahead, part C says, use the data provided to calculate the concentration of sodium hydroxide in moles per decimeter cube. So now you need to find the number of moles and volume. So the volume of nitric acid in decimeter cube multiplied by the concentration, okay, will give you the number of moles, because moles is basically concentration is mole per decimeter cube. So if I am multiplying the concentration with volume decimeter cube cancels decimeter cube, and I'm left with only the number of moles. So I get the number of moles here, and I'm going to re-emphasize this question in the next video.